All right. So something else that is really important that I want you to know about how neurons function is just that there are certain factors that will influence the amount or the rate of neurotransmitter release. So this is something that, we always talk about the action potential being all or none. And so it sort of feels like the firing of a cell is binary, right? Either it happens or it doesn't, which is true. But there are things that influence how much of the neurotransmitter is released. And that's going to be really important when thinking about the effects that these things have, right? When you think about neurotransmitter release. So that's the last thing that I want to talk about is what are the things that influence the amount, right, or the timing of neurotransmitter release. And the first thing I think is pretty simple, and most of you probably know, at least intuitively, is that while any one action potential, right, is an all or none thing, how fast that happens can change. It can vary, right? So the firing rate. And so we equate the perception of stimuli with the rate of firing. Something that is a very weak stimulus. So if there is a weak light or if somebody touches us very lightly, we're probably going to have lower rates of firing than if you have a very strong stimulus, right? If somebody really pushes down when they touch your arm, right? Or if somebody has a really bright light or a really loud sound. And the faster the rate of the action potentials, the more neurotransmitter is going to be released. Because if you're thinking about exocytosis, which was on your basic review assessment, every time that action potential reaches the presynaptic terminal, it's allowing calcium to come in and it's allowing for that process of exocytosis. So more action potentials per length of time means more neurotransmitter release. And this is related to refractory periods. So this is not something that I put on the basic review assessment, and I'm not really going to hold you accountable for it. But just to sort of remind you that when you have, right, like the time course of any one action potential, we start at negative 70 millivolts. And then you're going to have some EPSPs and IPSPs. And so this is going to be graded in here, right? But if you have enough EPSPs to get you to a critical threshold, and on this figure it's negative 65, I know some other figures, right, or other textbooks sometimes use different numbers here, negative 65, negative 60, but you're going to have these voltage gated sodium channels open. And then you're going to have this massive influx of sodium that will massively depolarize the cell. It will go right up until like the membrane potential is reversed. And then you have this process of potassium, right, leaving the cell as a function of all that sodium coming in, and the cell will repolarize. So the two important things on here that I want you to pay attention to are just that between the time that the sodium channels open and this point right here, they cannot open anymore, right? Like they are already open. And so in this period that is represented in sort of the salmon color here, you cannot have another action potential at that place on the cell, right? So let's say we're measuring from the axon hillock, right? You have one action potential. You cannot generate a second action potential until you get back to this space. Or this place. And so that puts an absolute limit on how many action potentials you can have per rate of time, right? Puts a limit on the rate, and also the fact that the action potential can't go backward, right? Like that is related as well. So that absolute refractory period, you absolutely cannot have a second action potential. But in this yellow part here, remember that you come to this place where so much potassium has left the cell that you are slightly hyperpolarizing the cell. This is not an IPSP. Yes, IPSPs hyperpolarize the cell, right? But there we're talking about trying to get the cell to that critical threshold. This is after the action potential, right? So this is a result of all that potassium leaving. You've hyperpolarized the cell. But the result is you cannot, you cannot have an action potential in the absolute refractory period. In this relative refractory period, you can generate a second action potential, but it's a lot harder, right? Because the cell is hyperpolarized. So it is completely possible because the sodium channels are now capable of reopening, right? It could happen that you get back up to this threshold, but you need a lot more stimulation. And that relates to this, right? That relates to the intensity of the stimulus coming in. Because if you have a weak stimulus, then you are not going to be able to get back to that negative 55 threshold, right? You're going to be hanging out here and you might depolarize back to resting potential, but you're not going to be able to get to here. But if you have a strong stimulus, right? If somebody turned on a bright light and you have very fast rates of a presynaptic cell firing, then what's going to happen is you are going to be strong enough so that you can, as soon as the sodium channels are capable of reopening, they will do that. And you can generate a second action potential. And thus, you are at the absolute limit of how many action potentials you can generate over a period of time, which means they are going as fast as they can, which means that this cell too, right, will release a lot more neurotransmitter. If you have to wait, to come back up to baseline because you have a weak stimulus, and it's not until you get back up to here that you can generate a second action potential, that's going to be a much slower, right, rate of firing, which means that this cell is going to release fewer neurotransmitters, which means that there will just be a weaker, right, interpretation of that stimulus overall. So even though the action potential is all or none, these channels open or they don't, how many of these can happen at one point on the neuron over a period of time can vary. And the faster they happen, the more that cell is going to release a neurotransmitter, the more of an effect it will have.